Hello, we are Team 3, the Shard. Urban Seller, the developer of the Shard, wanted the Shard to be a particular city with a variety of uses. The Shard is designed as a building which can perform various uses for each level. To make space suitable for each application, an optimized design was needed which was not constructible with one structure and one material. So, constructors divided the composition of the building into three parts. First, the Shard's largest and lowest part is used as office. There will be various arrangements for each office's purpose, so lowest level of the Shard, which has changeable open space, is suitable for office. To make large open space, designers had to reduce the obstacle like columns. Composite beam structure is suitable for this. Due to this structure, very few columns are needed inside the area. The shape of the beam is key point to make space without columns. The compound beam consists of 500 mm honeycomb beams and concrete slabs. Holes of beam increased length of web, therefore moment of inertia of the beam is increased. The increased moment strength could make 50-meter long beam without columns. And office needs air conditioning, ducts, piping, cables. Honeycomb beam made it possible to make the ceiling very thin, so the height of each floor could be reduced, which increased number of floors. Middle part of the Shard is used as hotel and apartment. Hotel and apartment need sound insulation and damper for comfort of residents. Concrete structure was suitable for these needs. Concrete has high specific gravity, which is proportional to sound insulation. Also, as concrete slab is thicker than composite slab, the sound insulation performance of residence floor is better than office floor. And due to concrete's heavy weight, concrete part provided damping to minimize lateral acceleration and reduces the swing of the building by wind. And for the profitability of the hotel and apartment, designers had to put many floors in the limited height, which they wanted to reduce the thickness of each floor slab. So, the Shard used post-tensioned concrete slab instead of normal concrete slab. Therefore, the downstand beam could be removed, thickness of the slab was reduced. So, compared to composite beam floor, post-tensioned concrete floor reduced floor height 515 mm. So, extra 2 floors could be added. The top of the shard is used as observatory and radiator. High-rise part of the shard was not good environment for apartment because of small area. So the designers made the spire as observatory and radiator. And because of small area and high height and fast wind, this huge steel structure could not made at the site. So engineers adapted module method. To lift modules, each module must be lighter than 7 tons, which is capacity of tower crane. Each module was prefabricated in the factory of Silverfield, Rouen at Susk, United Kingdom. To assemble spire with no mistakes at site, constructors pre-assembled entire spire at airfield of North Yorkshire. Each modules are lifted to site by tower crane 7 and assembled. And important problem exists in this high height structure. High-rise buildings need to pay more attention to lateral load management. At this high height, lateral load such as wind load must be considered because wind pressure is getting stronger as height goes up. Actually, in strong wind, the shard is intended to move up to 50 cm. To take lateral load, engineers designed head truss in level 66 to 67. Head truss distributes lateral load applied to core to perimeter columns, so reinforces lateral strength of the building. It is like ski pole. When you are skiing, something pushy you lateral. Your arm is head truss and perimeter column is ski pole. But there was two connection problem at perimeter column. First, there was a problem with the perimeter column span between the composite part and concrete part because of the use of other materials. The perimeter column span of concrete floor and steel floor are different. To make concrete slab without downstand beam, the limit of perimeter column span was 3 meters. Engineers found the solution to connect these two different columns. As a solution, in level 37 to 40, top of the steel levels, blended truss changes the span of perimeter column from 6 meter to 3 meter. And there was another problem in perimeter column. The shard seems to have a smooth tapered form, but look closely, it is not. The slant perimeter column transferred to vertical column by a load sharing system. There is even column setback exists. The inclined perimeter columns step back towards the core because of limit of ground level. Therefore, the changes of direction generates substantial horizontal push and pull forces. These tension forces are transferred to the core by horizontal steel struts. The horizontal load moves from the perimeter column to the core, and core load is transferred to foundation. The shard used a pile left foundation to take huge load. Unlike the left foundation, the pile left foundation disperses the load to the piles. A shard left directly below the core, which is expected to take concentrated load, was designed as 3 meter thickness, and the rest designed 1.5 meter thickness. In this huge scale of left work, the problem of dry shrinkage cracks in concrete was important. To solve this problem, the shard used GGBS concrete. GGBS has low hydration heat and low dry shrinkage. GGBS concrete mix doesn't attain full strength until 56 days, compared to normal concrete get enough strength in 28 days. So the ready mix was further modified to make sure that enough strength was available at 14 days for work to proceed core construction. Moreover, there were many things to be careful about the ground where the foundation was installed. The shard ground layer consists of alluvium, river terrace gravel, London clay, Lambeth group, Sanded sand. There is groundwater between the London clay and Lambeth floors. Due to silly clay's property, London clay has much boiler water, which causes volume change of the soil. When the persistent water deficit develops as a result of leaks from water supply pipes or drains, subsidence of the building can be occurred due to shrinkage of the soil. To prevent change of the soil, the shard construction team used secant pilewall to cut off the vein of groundwater and prevent movement of the soil. It consists of primary piles and secondary piles. Primary piles formed a cutoff to the groundwater in the London clay, and secondary piles have 53 meter depth bearing in Dunnet sands, which have more strength and safety comparing to London clay. When construct secant pilewall, there were many problems with the surrounding facilities. The shard is located just beside London Bridge Station, and the London Bridge Station is arch structure. Because the arch structure and the construction of the shard was too close, and arch structure was built long time ago, so it could be collapsed by construction. Therefore, constructors of the shard monitored the movement of arch structure. When movements were more than halfway through the slight damage range, amber alarm would be triggered, and red alarm is triggered when movement reached the lower and end of moderate to severe damage range. And there's a fault underneath the shard ground layer, divided east and west. The fault made East Lambeth Group's elevation of top of strata 5 meters lower than west. So, longer piles were required on the east side of the site. And this is graph of pressure limit and elevation. Focus on Dunnet sand layer. Pressure limit decreases from minus 54 meter. So, the piles were founded in the Dunnet sand at a depth of approximately 55 meter below ground level. And main bearing piles supporting the left have 1,800 mm diameter, as well 1,500 mm diameter, which is similar to secondary piles. This optimized left hand pile minimized amount of excavation and material use. Constructors of the shard used rotary board piling method to make second pile wall and foundation piles. This piling method has advantage that has minimal ground disturbance, which means limited risk of damage to adjacent structures. First, excavate the soils to make piles. Second, insert steel cage. Lastly, pour concrete to make piles. After piling, the shard's challenging attempt began. Constructors tried to use top-down construction to skyscraper construction by installing a plunge column on foundation piles. Top-down construction is construction method which excavates underground and constructs core simultaneously. After the piling, constructors excavated to level basement 2. After basement 2 excavation, core slipform is installed above plunge column and core construction is started. Simultaneously, excavation to basement 3 is started. When core reached 21st floor, basement 3 excavation is finished. And after basement 3 excavation, constructors started left concrete pouring and connected core wall and left. After left finished, top-down construction is completed. As a result, they reduced construction time at least 3 months. Step-by-step excavation and construction, both ground and basement floors. Each characteristic shows much more faster speed compared to traditional bottom-up construction. In fact, shard is constructed for 35 months from 2009 March to 2011 December. There was a reason why the shard adopted the time-saving method. The construction of the shard was delayed due to the 2008 financial crisis, and it had to be completed before 2012 London Olympics. To meet deadline, shard applied many methods to reduce construction time. One of them was the shard's crane solution, which goes up with slipform. Core crane was attached to the core shaft. At the base of core crane, Wheels on the base ran on guide track of the shafts to keep the crane vertical. By this method, slipform didn't stop while crane moves upward, which happens in normal construction. Therefore, core construction delay was eliminated. In addition, core cranes are less affected by wind, so there was less risk of collapse and there was no risk of construction interruption due to wind effects. By this way, the shard could shorten the time. After completing core construction using the slipform method, tower crane 7 is installed by tower crane 1 for spire construction. And tower crane 7 dismantled tower crane 1. After the installation of the spire, the disassembly process began. First, when lowering the crane, it went down to a 70-tooth floor by using hydraulic pressure, and removed TC7 by recovery crane. And recovery crane is removed by spider crane. And the components of the spider crane and recovery crane are lowered to the ground through the external hoist. So, the construction of the shard is ended. The shard became highest building and landmark of London. Thank you for listening. We are Team 3, the shard.